Hey guys, welcome to another video here on the AviationPro channel. In this video I'm going to tell you all about flying Oceanic on VATSIM. Now in this video I'm going to take you through flying Oceanic procedures. I'm going to tell you a little bit of theory behind it and talk about the North Atlantic structure and the NAT tracks that are associated with it. And I'm going to show you everything. So I'm going to show you how to plan a flight properly, whether you're flying eastbound or westbound. And I'm also going to show you the phraseology that comes with it. So talking with ATC and doing it properly when flying Oceanic. Because flying Oceanic comes with some special procedures. It's not your everyday flight. So it is interesting to cover that in this video. Now remember to use the description if you want to skip to certain segments. But I would definitely recommend to watch the entire video to really get a grasp and understanding of what I'm talking about throughout the rest of the video. So make sure you stay tuned and we'll get started. So first of all, you might think, isn't that crazy to fly Oceanic or long haul in general, like sitting in front of your computer for 7 or 12 hours straight? And yes, it is kind of crazy, but there are some things what make long hauls and especially Oceanic flights so interesting. First of all, it's just kind of a cool idea to fly over this big splash of water, to cross the pond and to see Europe or the US approaching when you've been flying over water for hours. It kind of is a cool feeling. And especially when you fly from the US to Europe and you see that the sun is rising in Europe as you arrive, that's just an amazing sight. And one more reason I would think of, like when you fly from Europe to the US, as you arrive in the US, you arrive in an entirely new culture, a new type of airspace, a new accent, and that's kind of fun as well. So, by flying long haul, you don't stay within your niche, you actually explore other regions, which is great fun. So let's talk a little bit about Oceanic flights. In this video I'm going to specifically focus on the North Atlantic, so North Atlantic Oceanic crossings. Main reason is because this is the busiest airspace in the real world and also in VATSIM when it comes to Oceanic flights. And of course there's the biannual Cross the Pond event on VATSIM where a lot of hundreds of flights go either from Europe to the US or vice versa. So this is really the most interesting region to look at. But some of this knowledge might also apply for other Oceanic flights, for example flying over the Pacific or in the Oceania region. So what makes flying Oceanic so interesting? Well, you're basically flying over this big splash of water without any radar coverage, and this makes it very interesting in the real world but also on VATSIM. Basically you have to do position reports and let ATC know what your position is, and based on that ATC will make sure there's enough separation between the traffic that is flying over the ocean. And believe me, if you look on Flight Radar 24 any time of the day, you will see a lot of traffic traveling from Europe to the US and also later in the day from the US to Europe. It's a very busy airspace, and this is definitely visible on VATSIM during the Cross the Pond event. So without radar coverage, you somehow have to separate this traffic, and that makes it very interesting. So let me review and discuss the North Atlantic airspace for a little bit. So the Oceanic region consists of virtually all non-domestic airspace over the ocean and the North Pole. It's controlled by the following 7 Oceanic control areas or flight information regions. All the way in the north we start with Nuuk, then we have Reykjavik, Gander, Shanwick, New York Oceanic and Santa Maria. So these are all regions where you will get Oceanic ATC, and if you fly here you will be in Oceanic airspace. Now if you look at sky vector, you can get an idea of the Oceanic airspace. And if you zoom in, for example, here on the boundary on the east side of the Oceanic airspace, you can see the various entry waypoints. And when you cross these waypoints, you enter the Oceanic area. And you travel the Oceanic area by flying via coordinates instead of waypoints that you would normally fly over when you fly over land. Now a basic rule of thumb is when you fly west to east or vice versa, you travel in steps of 10 degrees of longitude. So for example, you could start at a waypoint called Mallet, and then your next waypoint could be, for example, 53 north, 20 west. And then if you travel further westwards, your next waypoint could be, for example, 52 north, 30 west. So you can see that's a step of 10 degrees longitude. Now when you fly a more north-south oriented route or vice versa, these steps may be reduced to 5 degrees of longitude. So in that case the steps would be 5 degrees of longitude instead of 10, simply because you're flying more north to south route. So of course making steps of 10 degrees would be way too much. Now in the oceanic region, all airspace above flight level 55 is Class A, so controlled airspace, and everything below it is Class G, or uncontrolled airspace. But do keep in mind there's actually no radar coverage over the water, but it's still controlled airspace because you have to keep in touch with the radio. Now, of course, separation is vital when flying over the ocean. Because you don't have that radar coverage, you really need to adhere to rules to separate aircraft properly. So here's how traffic is separated over the North Atlantic region. So aircraft flying over the North Atlantic region, and especially those that are flying via North Atlantic tracks, which we will discuss a little bit later, are separated in several ways. First of all, vertically, there's always 1,000 feet separation for aircraft flying between flight level 60 and 280, and also aircraft flying in VSM airspace, so between flight level 290 and 410. Any aircraft above flight level 410 is separated by 2,000 feet. Now laterally, aircraft are separated by 1 degree of latitude. So 1 degree latitude is kind of like the axis of the wings. So the aircraft flying next to you is 1 degree of latitude away from you. Recently though, with the North Atlantic tracks, they also have reduced lateral separation minima. So only certified aircraft are able to fly as close to each other as half a degree of latitude instead of 1 degree. And of course you can imagine doing this will allow more aircraft to fly close to each other, and more aircraft to cross this already digested airspace. So there's more room to fit more aircraft in this way. Now as for longitudinal separation, which is along the body axis of the aircraft, so the aircraft behind you or in front of you, there's a time separation of 10 minutes for aircraft flying the same route at the same flight level. This separation is really important, so timing is adjusted based on the speeds of the aircraft and their estimated time of arrivals at different points along the route. And this is especially important for NAT tracks because we have to do position reports in order to remain separated from other traffic. So these position reports are vital to maintaining that longitudinal separation of 10 minutes. So this is the basic idea of the North Atlantic airspace. You now have an idea of its structure, the entry waypoints, how you fly via coordinates, and how traffic is separated. And now we're going to talk about NAT tracks, because NAT tracks are very essential for the everyday flying between Northeast US and Europe. Now, because the airspace above the North Atlantic is so congested, there are so-called North Atlantic tracks over the North Atlantic Ocean. These tracks are designed to structure the flow of traffic over the Oceanic region, mainly for flights going from Europe to the northeast coast of the US and vice versa. Simply because there's so much traffic between these airports, you need some system in order to stack all traffic flying to and from these regions. Now, to accommodate all this traffic while adhering to the separation minima for the North Atlantic airspace that I just talked about, these NAT tracks are established. They are established in such way as to accommodate traffic going from Europe to the US in the morning and afternoon in the UTC time, and to accommodate traffic going from the US to Europe during the evening and night in UTC time. So the way NAT tracks are established mainly depends on the so-called jet stream over the Atlantic Ocean. Now, the jet stream is a meteorological phenomenon where, thanks to the dynamics of the ocean and the air above it, a jet stream is present flowing from west to east over the North Atlantic. So this is a region where there are high winds. Now, when looking at sky vector, you can clearly see this. The green lines represent the NAT tracks going west, so from Europe to the US, and the blue lines represent the NAT tracks going east, so from the US to Europe. When turning on wind barbs, you can see how the NAT tracks are designed on a daily basis. Basically, for flights going to the west, they try to avoid the jet stream in order to reduce headwind and also to avoid turbulence. That's why you can see that the NAT tracks are either below or above the jet stream, depending on its location that day. As you can see on the map, indeed, the NAT tracks going west actually try to avoid these heavy wind areas as much as possible. However, flights going east want to make use of this jet stream in order to increase their tailwind and to make the flight more economical. Hence why east tracks are located in the jet stream depending on its location. So again, on Sky Vector you can see how the east tracks actually follow the wind barbs, where the wind barbs are the strongest, in order to get as much tailwind as possible. So these NAT tracks are not just designed to accommodate all the traffic in a proper manner, they also are designed in order to make use of the jet stream as much as possible or to avoid the jet stream as much as possible, depending on which direction you're going. Now actually, if you've ever flown from Europe to the US and back, you will notice that your return flight to Europe is a lot faster, because thanks to the jet stream and thanks to these NAT tracks making use of the jet stream, your tailwind component is huge. Sometimes the aircraft really fly close to the speed of sound when looking at the ground speed. Of course, the true airspeed is different because the air mass is moving as well, but some high speeds are achieved there. In general, those flights are therefore a lot shorter in time. So now the question is, do I have to use these NAT tracks every single time whenever I fly to the US? Like if I fly all the way to Seattle, do I have to use the NAT tracks as well? Well, no, that's not the case, because there's also something called random routings over the North Atlantic. And in fact, a lot of flights in the real world make use of random routings. So as explained, in steps of 10 degrees longitude, you can basically fly your own route, any route over the Atlantic Ocean and also over the North Pole. And if you're flying in a north-south direction, for example, if you're flying from Europe more towards the Caribbean, you can do this in steps of 5 degrees of longitude. And in fact, you can even cross NAT tracks that are active using random routings, although you will probably face a lot of restrictions by ATC, and they will probably not be very happy with you trying to cross all those active NAT tracks with your random route. Now, the way to think about NAT tracks is that this is in general for flights between Europe, Western Europe, and the northeast coast of the US. So for example, flights from New York JFK, Boston, Chicago, if those flights go to Heathrow, Amsterdam, Paris, Frankfurt, those flights are likely to use NAT tracks. And we'll take a look in a minute in the flight planning phase of this video to see whether it's useful to fly NAT track or not. Before we look at flight planning, one more thing about NAT tracks is that they are established on a daily basis in a so-called NAT Track Message. Now you can easily look this up on Google, simply type a NAT Track Message and usually the first link will produce a nice result. The thing with those NAT tracks is that they're only valid for a limited period of time and they are only released at a certain time point during the day. Because of course, depending on the position and conditions of the jet stream, the NAT tracks are altered. So typically westbound tracks are published at around 2200 UTC and remain valid from 11:30 UTC the next day till 1900 UTC. Eastbound tracks are published usually at 1400 UTC and remain valid from 1 till 8 UTC. So as you can see, those NAT tracks are really not that active for a long time, and they're basically designed for when the major flow of traffic in the real world is actually crossing the ocean. Any traffic that flies outside of this valid time period simply uses a random routing. Now this random routing, just flying from coordinate to coordinate might actually be exactly the same flight path as a NAT track will be in a couple of hours. But legally, it's not a valid NAT track yet. So in that case, if you're flying outside of the valid time period, you'll basically just be flying a random route instead of a true NAT track. So to determine whether you need to file a random route or to actually file a NAT track, one way you can look at this is by looking at what time you will cross the 30 West waypoint. And this 30 West is basically the borderline between Shanwick and Gander Oceanic areas. If you cross 30 West within the valid time period of the NAT track, then you can safely file the NAT track. If not, if you happen to arrive earlier, for example, then just file a random route, and you can, as said before, you can just use the same waypoints that are on the actual NAT track. Because the NAT tracks themselves are also just a collection of coordinates, going from 20 West to 30 West to 40 West, for example. All the NAT tracks are that they are just fixed routes that are flown within a specific time period. But if you don't enter that period on time, you just file random routes using the same waypoints. So far for the NAT tracks in North Atlantic airspace, it might seem a little bit vague at this point about what NAT tracks really are and how to deal with all this. But we're now going to take a look at flight planning. I'm going to show you a couple of ways how you can determine the route, and of course we're actually going to fly the flight, and I'll simulate ATC and how to talk to ATC, and how and when to ask for the Oceanic Clearance, for example. This is all part of it, so it will really all come together towards the end of this video. For now, let's take a look at flight planning. Okay guys, so we're now going to take a look at the flight planning part of this tutorial video, and first of all I here have today's NAT Track Message, so we can kind of go through it and decode it. So it's pretty straightforward. It seems like a lot of text, but you just have to take this step by step as usual. So we have the NAT tracks between flight level 320 and 400, valid on May 24th from 1 Zulu till May 24th on 8 Zulu. Now, so these NAT tracks are only valid for another 13 minutes, but that's okay. As you can see, these are the tracks that go from the US to Europe. So these are eastbound tracks. So usually it comes in a couple of parts, and right here you have the first NAT track, Romeo. And you can see it starts with the oceanic entry waypoint, in this case Ellery, and then you have the different coordinates which this track follows. So 51 north, 50 west, and in steps of 10 degrees, so 52 north, 40 west, 54 north, 30 west, 55 north, 20 west, Resno, and then Netki. Usually there are either one or two waypoints at the end where you leave the oceanic region. For this track we have eastern levels, so these flight levels are able to we are able to use as flight level once we cross the North Atlantic, so 320 all the way till 400. As you can see, the west levels indicates nil, meaning that there are no levels available going west because this is the eastbound track. So then right here we have some more information. As you can see here, European routes east also nil. Well, this means that there's no specific route that will take you from the NAT track to Europe, after you leave the NAT track to enter European airspace. You just continue and fly any domestic route that you want. But in the US, what you often see is that there are actually particular routes that will take you from the NAT track to the US, and also from the US, from the domestic route to the NAT track, and these are called the North American routes. As you can see, these are indicated right here, November 389 Bravo and November 383 Bravo. So I'm just going to take a look at SkyVector to show you this right here. So we were talking about track Romeo. As you can see right here is track Romeo. Indeed, it follows the same waypoints as in the NAT Track Message, so Ellery, all the coordinates, and then Resno and Netki. And what I mean by the North American route is this one. So as you can see, from some kind of waypoint right here, you'll end up on this airway, November 389 Bravo, and this will take you to track Romeo. And same for the other one that we also mentioned, November 383 Bravo, that will take you to track Romeo. And so for every track basically from the US, there's this North American route that will take you from a domestic waypoint or VOR, for example, to the oceanic entry waypoint to get you on the NAT track. Now the same for the westbound tracks. So from Europe to the US, there's also a lot of airways, as you can see here, where this track Echo ends. There are a lot of airways, there's North American routes that will take you further into US airspace to continue your route domestically. So just keep that in mind, that on the North American side, those routes are there, so to take you from the NAT to the US and from the US to the NAT track. But in Europe, you can basically fly any route you want. You just leave an airway, and then you pretty much direct to the first waypoint on the NAT track. But we'll take a look at that once we go into flight planning. So to continue with the NAT Track Message, for each and every track that's active, you will here have the information about it. So the coordinates that it follows, the flight levels that are available on this NAT track. As you can see on this particular NAT track Sierra, there are only limited amount of east levels available. And here you again have those North American routes to enter the North Atlantic track. So basically different parts, you have all the different NAT tracks. And this is the last one. As you can see, there are a lot of NAT tracks today for eastbound flights. Now, what's important is the remark section. Here are any remarks that are, have any relevance about flying over the North Atlantic when flying across North Atlantic tracks. So make sure you give this a review. Make sure you're aware of the remark section, okay? Because otherwise you might miss out on important information, especially when you do cross the pond event. So make sure you read that through. Once we scroll further, we go to the NAT tracks that are established this morning for flights going from Europe to the US. As you can see, those NAT tracks, instead of starting at Zulu, the end of the alphabet, these NAT tracks going westbound start at Alpha, so the beginning of the alphabet basically. So right here we have track Alpha. As you can see, it starts at Eraka waypoint, and then again the different coordinates. As you can see, these waypoints, these coordinates are much more north, probably because of the jet stream again. And this NAT track ends at Savory. So again, for all the westbound tracks, you have the same procedure. You just have all the different NAT tracks that are available. As you can see, there are only limited NAT tracks available today for westbound flights. And again, make sure you give the remark section a review. It's very important. Alright guys, so I'm now going to plan my flights and I'm going to show you different examples depending on what kind of route you're flying. So I'm going to start off with a flight from Amsterdam to New York JFK Kennedy. And basically I'm going to be flying this flight via NAT track. Now I'm going to be using PFPX. You can safely also use SimBrief. I'm not going to go too much in detail regarding PFPX itself. What is most important is actually finding a good route, and even PFPX usually does not do a very good job at that. So let's just go ahead and start. We'll add a flight. So I'm going to be KLM 641, which is a real-world flight from Amsterdam to JFK. So there we go. And well, I'm just going to depart, let's say, at 11 Zulu. Well, actually maybe a little bit earlier. It could be 10 Zulu. And I'm going to be using the Boeing 777 for this 300, since that's the only 777 that I can use with PMDG airplanes that KLM actually has. So there we go. We're just going to save that and we're going to plan the flights. Okay, so as you can see, it already draws a direct route, which already gives you some information, because if you turn on the NAT tracks right now, you can do that right here. You can also check this out on SkyVector, of course. If you turn on the NAT tracks, as you can see, they're pretty high for our flight, and you might wonder, is it actually beneficial to use a NAT track? Well, yes, it probably will be, because the winds right here, for example, flight level 350, are pretty strong, and that's the jet stream that I was talking about, and that's where actually the eastbound tracks are. So you don't want to fly very low. So in this case, it's definitely as with any northeastern airport on the US coast, we definitely want to make use of NAT tracks. So which of these westbound NAT tracks to use? Well, we'll take a look, we'll see what happens. I'm just first gonna prepare here the setup. Let's say we have a takeoff from runway 26 left, arrival runway is fine for now. This is all good. We're just gonna give it a random payload, looks fine. Get a little bit of extra time, a bit of hold time. That should be okay. And then we have the route section, and this is the most important section that I want to focus on. So let's see what happens once we click find. So there we go, and as you can see, it comes up with actually a random route, and it's very interesting, isn't it? Well, basically PFPX at this stage thinks, okay, it does not make sense to fly via NAT track because apparently this is too far north or something. Well, in reality, actually here is the jet stream present, so it really makes no sense to fly this direct route, to fly in all this headwind. Actually, I do want to fly via NAT track, so we have to come up with some other way to find a proper route. Now, since PFPX usually doesn't do a very good job at flying via NAT tracks, you could try to force it to fly via NAT track by using the advanced route finding function, like here. So you can just enter some waypoints along the track to try to force to use the NAT track. But what I personally use for flights from Europe to the US is Route Finder, and this is a website that also finds routes. And usually it is not very accurate for domestic flights, but I found that for North Atlantic flights it's actually pretty accurate. So just put in the departure ICAO code and the arrival ICAO code, and then any flight level will do. And then current ARIC cycle, and then also you want to make sure that SID, STARS, RNAV, and NATs are enabled. And just gonna find route. And the benefit of Route Finder, as you will see in a short moment, is that it actually makes use of the NAT track when you enable it. As you can see here, it comes up with a route. It may be a little bit hard to see. I'm just going to copy it to PFPX. So I'm going to edit the PFPX route right here, and just going to plug it all in and let it build. And as you can see, we now have a route that flies via NAT Track Echo right here. As you can see, it's included right here. So another benefit of Route Finder is that it will actually make use of the North American route that I talked about. So here, November 675 Alpha is indeed the the North American route that takes us from waypoint Yanyo all the way to the next waypoint Ebony. And that's, if you look at SkyVector, that's indeed correct. So Track Echo, which will take us to Yanyo, and then we have one of these North American routes that will take us to the next waypoint for our arrival into JFK. So I'm just gonna validate this, see if it comes up with any issues. It probably will. Oh, actually it doesn't. That looks very nice. So as you can see, using another source for your route can actually be beneficial. I think Route Finder sometimes does a better job at finding a proper route via a proper NAT track. Okay, so just keep that in mind. And of course, you can just kind of play around with PFPX yourself as well. Try different tracks, see which flight will be the most economical depending on which track you fly. In the real world, they have advanced flight planning tools for this and dispatchers. So I would not bother too much with this, but in general, for flights from Europe to the US, I think Route Finder is a pretty good option. So once you've built up the route, just make sure that the NAT track is actually correct. So make sure you check all the waypoints of this NAT Track Echo. Make sure it's correct as in accordance to the current NAT Track message and for the time period that you're going to fly into. And then we're also going to take a look at another type of route when we go eastbound. So now I've just quickly set up for an eastbound flight, and as you can see, I here have the NAT tracks flying from Chicago to Amsterdam. And I'm gonna use the find function, see what it comes up with. As you can see, again, it comes up with a random routing that will take us straight through the westbound tracks. Actually, we just want to make use of the NAT tracks. Now, again, using the auto-generate function usually does not produce a good result in the first place. But for eastbound flights, there are some other things to keep in mind. Usually from the US in different airports, for example, Chicago and New York, those kind of airports in that area, they're so-called preferential routes. And these preferential routes will, take you to the first waypoint where the North American route starts, and then this North American route will allow you to fly towards the entry point of the Oceanic area. So, in the real world, they have, for example, whereas this flight planner might let us fly via different waypoints and different airways, in the real world flight that's taking place tonight is likely to fly via a lot of directs and using routes in order to, again, just to manage the traffic flow across all these busy airports on the northeast coast of the US. So what I would recommend, and actually this is the most easy solution for eastbound flights, just use FlightAware. So I'm just going to go there right now. FlightAware is, and like FlightRadar24, it's a tracking website. But this website, gives some more information about the actual route that's being used. So, for example, we could just plug in Chicago O'Hare to Amsterdam. And of course, normally you would do this later during the day. For example, to get the latest route of KLM flight that will take place in 12 hours and 58 minutes. So I'm just going to click on this one, see if there's already a route available. And from what it looks like, there's indeed already a route available. Just to be sure, I'm going to select yesterday's flight here, KLM 48, sorry. And this is the route that it has flown. And again, you can just use this route basically. You can just copy this straight into your PFPX or any other flight planner that you use. And as long as you do this a couple of hours before the actual flight takes place, you'll be flying the same route and the same NAT track as the real world flight does. So that's pretty convenient. So if we just take a look at today's flight, which will take place in 12 hours, As you can see, the route looks pretty weird, and this is the preferential routing that I talked about. So this will take all the flights from Chicago properly to the North Atlantic track, so via all these direct waypoints, basically just flying from waypoints to VORs without flying via specific airways. And then right here, November 505 Alpha is going to be the North American route, and then via recall we travel via NAT Uniform. Now again, if I just look right now, just have to make sure. Probably NAT Uniform is something different currently. So as you can see, this route is probably not that valid at this stage, simply because it's too early into the day in order to get the correct NAT track and the correct entry waypoints. So you want to make sure that you check this route just a couple of hours before the flight takes place. So just to show you how this works, I actually copied the NAT tracks yesterday. So the NAT track that was used by yesterday's flight from Chicago to Amsterdam is going to be actually valid if I just copy this route. So here we have the route again, the different waypoints, the preferential route. And in this case, there's no North American route. It will just fly straight onto NAT Track Uniform in this case. And as you can see also, when we leave the NAT track, there's actually a route portion that will take us to Lomso, which is the standard terminal arrival route entry point at Amsterdam. So the European route is in there as well. Now for European flights, usually, if you depart out of Amsterdam and look for a flight to Chicago, not the entire route is in there usually. You might find some and actually use the real world flights route for a westbound flight, but usually only for the eastbound flights actually the entire route is in there. So I'm just going to copy this to PFPX. I'm just going to add it to route right here. Let's copy it straight in. Just going to let it build. First waypoint is going to be this VOR DME in the United States, and I might need to do some editing right here. It seems to be okay. You want to make sure that the NAT track is actually correct, and that the entry and exit waypoints are correct. So NAT Track Uniform, just to make sure, we'll check in a track message of yesterday. So right here we have NAT Track. Let's take a look. Uniform starts at UP. This is correct. As you can see, we direct to UP at some point. Then we have NAT Uniform via the different waypoints, and we end up at Mallet. That's part of the NAT Track Uniform right here, and then we direct to Gisti. So that seems to be correct. Just want to check on the map again. Okay, so UP, different coordinates right here, 40 west, 30 west, 20 west, Mallet, and then right here we end up at Gisti. So this route's indeed correct. So if I would just validate this, it should actually come up with no errors. Well, actually, you can see that NAT Track Uniform is not active because I copied yesterday's NAT track. So as you can see, this is the best method for eastbound flights, so just use FlightAware. So we now had a look at flights flying via NAT tracks, either westbound or eastbound, but there's one more example that I want to show, and that's by flying the random route over the North Atlantic or the North Pole. So in this case, I set up for a flight from Amsterdam to Seattle. Again, if you use the find function, PFPX will come up with some kind of route. As you can see, it provides a nice random route which will take us over Greenland and northern Canada. And this looks like a pretty good route, but once you validate it, especially probably in Europe, it's going to come up with a lot of errors, and so it does. So, with these kind of errors, sometimes it's very hard to find out what these errors are about. This is probably just restricted airspace for some reason, probably somewhere in Scotland, in that region, for example. And as you can see, there's another restriction. Now, I'm not sure how strict these restrictions are in real life, and if just flying this route would be best. But what you can do if you really want to try to get kind of a realistic route is by looking up real-world flight plans. Now, if you look at FlightAware, there's a flight from Amsterdam to Seattle 2 days ago, and as you can see, actually the route goes all the way over the Shetland Islands, over Iceland. I flew this route in real life, so I know what kind of route they're flying, and they usually fly kind of the similar route as well all the way over Greenland. And as you can see, that looks a little bit different from this route, which goes straight over Iceland and then over Greenland. So what you can do is look up real-world flight plans on the real-world flight plan database. Again, there's links in the description for all of this. So for example, from Amsterdam to Seattle, you can see if there's any flight plan that is recent. Well, this flight plan is the most recent one, but it's kind of old. So what you can do in this case, just try to look for an airport or route close to the destination airport. For example, Vancouver is very close to Seattle, and you might be able to find more recent flight plans for this route. And so indeed, we have here KLM 213 flight of the 31st of March. So we're just going to take a look at that one. As you can see, it provides a nice route. So let me just copy this and see what PFPX comes up with. Okay, so now copy the PFPX or the route into PFPX and build the flight plan. As you can see, this route is actually looks a lot different. It looks kind of like the route that normally Delta 143 from Amsterdam to Seattle also flies. So you might need to make some adjustments here at the end of the route, but at least this looks a little bit more close to reality. Now, of course, this also depends on winds, all right? Picking a flight plan from months ago, the winds might have been way different, and actually a route towards the south of Iceland might actually be more fuel efficient. But again, using an auto-generated route like the one here in PFPX does not really take into account the wind that much. So you might need to make some manual adjustments here. But if we validate this route, let's see if we can come up with something. Well, actually there are some more restrictions, as you can see right here. So just copying in old routes from a real-world flight plan from months ago does not mean it will be valid that much. So in this case, actually using the route that PFPX came up with is just probably better. So I'm just going to clear that, find a route, and I will probably just fly this one in this case. So, but just to show you, you can use the real-world flight plan database to look up routes. Sometimes, just kind of by combining the route that PFPX gives and the real-world flight plan gives, you can kind of come up with your own route. But again, don't fiddle around with it too much. I mean, it's VATSIM after all. It's not the real world. So at some point, you just have to go and enjoy your flight. So as you can see, I'm now back with my original flight plan going from Amsterdam to New York JFK. And I've now just used the route finder route again, just flying my NAT Track Echo. And when it comes to flight planning, I hope you, by the way, have now a good idea about the different ways of getting a route. And as you can see, it can be a bit tricky. But one more thing about flight planning is ETOPS. And you might have heard about this acronym. It stands for Extended Twin Engine Operations. Basically, in the old days, aircraft had to be away from diversion airports for a maximum of 60 minutes. Now, with today's airplanes, they become more reliable. And usually in the past, you needed tri-jets or aircraft with 4 engines in order to cross the North Atlantic properly. But now mainly twin jets are more economical to fly with, and at the same time they are also more reliable due to technological advancements recently. So they don't have to be a maximum 60 minutes away from a diversion airport anymore. So what ETOPS means is that aircraft get certified to fly away from diversion airports for a longer period of time. So for example, an aircraft might have an ETOPS 180 certification, which means that the aircraft is allowed to fly up to 180 minutes away from a diversion airports if it would be flying on one engine. Okay, so that's kind of the way it works. So if one engine becomes inoperative, it has to be within 180 minutes of a diversion airport. And ETOPS ratings are really skyrocketing recently. I mean, aircraft are just getting so reliable, and the chance of the second engine failing as well is just very low. That these airliners are allowed to fly away from airports over large distances. So in PFPX you can also plan ETOPS, because of course you can imagine when flying over the North Atlantic over this big splash of water, you want to make sure that you have diversion airports close to you in case something happens. I'm not going to go in all kinds of emergency procedures when in this tutorial video, but you have to plan some ETOPS in order to have a diversion airport available when something happens. So right here you can select the ETOPS scenario. Now actually 777s have a lot higher ETOPS scenario, but just for demonstration purposes, I'm going to show you what I mean by this. So what you do here in PFPX is you enter so-called equal time point airports, and this is simply a pair of airports between which you're going to decide, okay, am I going to divert to this airport, or am I going to continue flying towards the next airport? I'm just going to show you in a minute what I exactly mean by that. So for example, a common diversion airport is, for example, Shannon in Ireland, and this all depends on whether there are facilities available at that airport, whether the weather is good enough to fly to that airport in case something happens, and of course, facilities like to treat the passengers and to treat the aircraft's technological malfunction, for example, all those facilities need to be there. So that's why you cannot simply pick each and every airport along the coastline right here. It really depends on the services that are available at that airport, and especially the navigational aids that are available at the airport. So for example, a common airport again is Shannon. So right here, Shannon, or you might also choose Dublin. I'm just going to pick Shannon for now. So I'm just going to put in the ICAO code. And then the next diversion airport, which is rather common, is Keflavik in Iceland. There we go. So what it's going to do, as you can see, it's going to draw these circles of 120 minutes. And as long as your route is within these circles, any of these circles, then you should be okay. Then the next pair of airports is going to be, for example, Halifax is kind of an airport that you can divert to. So the airport is right here, Charlie Yankee Hotel Zulu, and you can just gonna put in the next pair of equal time point airports. So right here we put in Keflavik, and then the next diversion airport is gonna be Halifax. There we go. As you can see, it will draw another line right here. Now, basically, here's a problem because we're not within 120 minutes of an airport when flying along this portion of the route, as you can see, because we're not enclosed in a circle. So again, using higher ETOPS certifications like 180 minutes does the job. So, but this just demonstrates that if you have an older aircraft with lower ETOPS certification, you have to be within a certain range. So in this case, we probably have to, for example, pick Gander as a diversion airport. So I'm just going to put that in. So now I've selected Gander as a diversion airport for the ETOPS portion of this flight, and now we're actually good to go, because now our route is within ETOPS airspace. Now, what do these equal time points mean, and why do I put these airports in pairs? Well, basically at some point along this route there's going to be the so-called equal time point, the ETP, and at this point you're going to decide, okay, am I going to divert to Shannon or am I going to divert to Keflavik? And if you pass that waypoint, it doesn't not make sense to return to Shannon anymore. Actually, if something happens, it makes more sense to divert to Keflavik. So then the next pair of airports where you're going to decide, okay, I'm going to divert to this one or this one, is going to be Keflavik and Gander. All right. Again, there's going to be an equal time point where at some stage it's more beneficial to go to Keflavik, but once you pass that equal time point, it's more beneficial to go to Gander. So, I mean, in practice, if you have an ETOPS rating of 180 minutes or even higher, like 330 minutes, you can just pick two diversion airports on either coast. Sometimes you might want to pick a lower ETOPS scenario just because you want to have more diversion airports. For example, if you don't want to fly for 330 minutes on one engine, you don't have to. You can select a lower ETOPS scenario to, divert to an airport closer to you. But this just goes to show you, that you have to make sure that you're within a certain range, at least within the ETOPS certification of your aircraft. You have to be within a certain range away from your airports, diversion airports along your route when you fly over the ocean. Now, just before I actually compute the flight, I've added one more equal time point airport, so I selected Philadelphia. Otherwise, not the entire route is within ETOPS range. So also over land, you want to make sure you're at least within 120 minutes away from your diversion airport. So I'm not going to compute the flight. Let's see what happens. Alright, so the flight plan has now been calculated. As you can see, we enter here track echo. And right here we have equal time point 1, and this is the point where we're going to decide, okay, are we going to divert to Shannon or are we going to continue to Keflavik if something happens? What you also see here is entry and exit. This is basically right here you have exit. This is basically the region where you enter ETOPS. So when you're more than 60 minutes away from an airport, you enter the ETOPS region. Okay. Here we have equal time point 2, so that's where we're going to decide whether we go to Keflavik in case something happens or whether we continue to Gander. Alright, and then here we have another equal time point where we decide whether we to go to Gander or whether we can go to our alternate Philadelphia. Okay, so that's kind of how the route works. You want to make sure you review your flight plan. Now, just make sure, for example, what is most important is to see when you arrive at your NAT track and at what altitude. That's very important. So right here we have a lot of waypoints, as you can see, and Resno is where we start our flight. As you can see, we are at flight level 340 by then, and we're 1 hour and 29 minutes into the flight. Okay, so of course you're going to put this all in the FMC so we can get more accurate calculations, but likely we'll be flying at flight level 340 on the NAT track. As you can see, PFBX does calculate a step climb in the NAT track, but in practice that's actually not allowed to do step climbs. It's very rare that you will get approved, especially during cross the pond and in the real world. So we'll probably just stay at flight level 340, and then once we exit the NAT track, we can climb straight to flight level 360 or flight level 350. It depends a little bit what the FMC says. But for now, we're going to estimate that we're going to be flying on NAT track Echo at flight level 340. So I'm just going to export the route right here, and I'm just going to export it to the PMDG flight plans and also to vPilot right here. Because that will make it easier to actually file the flight plan. So I'm just going to save that, and then we're going to start the sim and head into vPilot, and then we're going to actually load and file the flight plan. So I'm just going to load our flights here from Amsterdam to JFK here in vPilot, and just so you can see what the flight plan looks like. There are a couple of things that you have to keep in mind when filing the flight plan. Okay, so I just want to make sure that everything is correct. Okay, Amsterdam to JFK. Alternate airport is going to be Philadelphia. Departure time, let's say, is going to be 10 Zulu. Okay, 7 hours and 3 minutes. Fuel available, that's all fine. Our initial cruise altitude is going to be flight level 340. We're in heavy aircraft, and you also want to make sure you have the right equipment suffix in there. Okay, so we have our initial route. We start at flight level 340, and then we enter Resno. And right here, this is important. This is the MAC number that the flight will take place at. So of course, again, once we go to Oceanic Clearance procedure, you will notice that you have to report and request a MAC number for your flight. So we're going to expect that we are going to request MAC decimal 83 for crossing the Oceanic region NAT track Echo, alright, at flight level 340. Now, as you can see, it does include a step climb. I'm just going to remove that because it's not necessary, because we'll likely not be able to do a step climb anyway. So I'm just going to remove all this right here and do it this way. So we enter via Resno, we enter the track at MAC decimal 83 flight level 340, then we fly NAT Echo, and then our exit point is going to be Ñaño, and at that point, once we are exited, we can continue our climb. Then we have the North American route, which will take us to Ebony, and then we arrive in New York. Basically, you have the arrival route. All right. Now, here in the remark section, if you load directly from PFBX, you have some more stuff that you can view. Depends a bit on what your settings are. Maybe worth to mention here, you can see the en route alternates. So ATC knows what our en route alternates are. For example, Shannon, Keflavik, Gander, and Philadelphia are our en route alternates. Okay, so if this is all correct, especially if the MAC number and flight level at the Oceanic entry point is correct, you can file your flight plan to VATSIM.
Alright, so welcome into the Boeing 777 cockpit right here. I'm just gonna take you through some of the basic FMC setup. I'm not gonna go in full detail. If you want to have full detail about all this, you know, the regular flying stuff, make sure you check out my VATSIM 2017 tutorial series. But for now, what you want to make sure once doing an oceanic flight, you definitely want to have the correct amount of fuel and the correct amount of payload. Otherwise, your calculations are going to be incorrect and your max speed might differ, for example. or you might not be able to achieve the max speed that you originally planned. So just gonna take a look here at my flight plan. It looks like we got a release fuel of 62 tons. Let's make that 63 tons. Just to round it off above. There we go. And then the payload zero fuel weight for today is 223.777. 223.777. There we go. So the weight in the aircraft has now been loaded. All right. Now then we go back to the FMC. Nav data is already out of date, but doesn't matter for now. So what you want to do is, as you know, I've exported the route in PFPX so I can use the ACARS function of this aircraft. I'm just going to request it, 777 Amsterdam to JFK. There we go. We'll select that one and we'll request that route. Alright, and this is just going to pump the entire route that we planned with PFPX into the airplane basically. So the request has now been sent via the ACARS function, and soon we will be able to load the flight plan. There we go. We can load the flight plan. Route uplink is ready, so we'll load it. As you can see, route 1 is now loading, and we have Amsterdam, and we just have to input some more information. There we go. We're gonna depart from runway 36 left. Our flight number is gonna be KLM 641. There we go. And we're just gonna activate it for now. Performance, you can also request that. I'm just gonna make sure it's correct. Seems to be correct. We can accept this for now. There we go. And of course you also want to make sure you load the wind data, because thanks to this wind data your calculations will be more accurate. So make sure you go to the lags page, the route data, and then load that wind data. If you don't load the wind data, likely your estimations of arrival times on the North Atlantic track, especially when entering the North Atlantic track, are going to be inaccurate. So make sure you load the wind data before you depart. So we're just going to hit execute. Descent forecast, I'm just going to leave that out for now. So now for each and every waypoint, including the coordinates, we now have wind data available. So as with any flight plan, you want to make sure you check it, make sure it's okay. Make sure the NAT track especially is correct. So make sure you cross-check with the NAT Track Message to see whether NAT Track Echo is correctly in there. So we have Resno, then we have 56 North 20 West, 58 North 30 West, 58 North 40 West, 56 North 50 West, and Yanyo. And as you can see, according to the NAT Track Message, this is the correct NAT track that we'll be flying. Now, if you for some reason want to manually put in the flight plan, you can do that. I'm just going to quickly show you how you can enter a coordinate. So of course this depends on the aircraft manufacturer, so make sure you look up for your aircraft manufacturer how you can enter coordinates. In the Boeing it's pretty simple. Say we want to fly to 56 North 25 West, you enter it this way, so North 56 West 025. There we go. That's how you would fly direct to a coordinate, a random coordinate. And of course you can also do it with south and east, depending on which region of the world you're flying. So I'm just going to delete this waypoint out of here right now. An easier method, as you can see, it's already put in here. You can just put in 56 and then 25, for example, and then the N. So what this means is 56 North 25 West. It's going to be exactly the same waypoint, but it's just a different way of entry. And in this way, there are different ways of entering coordinates in the FMC. You can even put in more precise coordinates if you want to. Of course, when crossing the North Atlantic, that's not necessary, but those possibilities are out there. So this is probably the easiest way. So North 56 means, or this one 5625 N means 56 North 25 West. Okay, so I'm just going to delete that out of there again and erase that. This out of the flight plan. Now again, when you just load the flight using ACARS, there should be no problem. Okay, just make sure that all the coordinates are in there. Now what we do want to make sure is we want to check the route data and then look at when you're arriving at Resno. Okay, so if we would depart now, our arrival time at Resno is going to be 10:40 Zulu. And for our oceanic clearance, it's important to remember that we want to ask our oceanic clearance 30 minutes prior to oceanic entry. So by waypoint Barso, which we reach at 10 Zulu, we actually want to start thinking about asking oceanic clearance, alright? So then we have 40 minutes left until we arrive at the Resno. Now again, once we are up in the air, we're going to have the most latest information, but you can use the route data page to determine when you're going to arrive at this particular waypoint. Another thing you want to check beforehand is to make sure you cross-check with the FMC whether the speed and altitude at which you want to enter the North Atlantic track is correct. So in this case, it is indeed correct. We planned for flight level 340 at Mach decimal 83. Now once we're in the air, we probably want to round this off. So now it says point Mach 826. We probably want to go to the VNAV page at cruise and change our speed to exactly decimal 83. So that of course helps with the accuracy of flying the North Atlantic track, okay? But just want to cross-check at this point already, okay, with this weight, with this amount of fuel, do I arrive at Resno, at which we're going to enter the North Atlantic track, do I arrive there at the correct flight level as planned per the flight plan, okay? So that's the basic FMC setup for you. Alright, so before we depart, we have to talk about oceanic clearance. And oceanic clearance basically means that you get a clearance to cross the North Atlantic, whether that be flying via North Atlantic track or via random routing. You need the clearance before you can enter that area. Now the thing with flying over the Atlantic is that in the real world, pilots get clearance via the so-called ACARS function of the aircraft, or data link. So they basically just receive a text message which they can accept, and that's their oceanic clearance done. You can also ask via voice in real life, but it's not as common anymore. Now in VATSIM, there are also two ways to do it. You can either ask via voice with the relevant controller, and it's wise to do this 30 minutes before entering oceanic airspace, or you can ask via a private chat, just to kind of simulate a data link. So you just send a chat message to the relevant controller, a private text message that you want to ask clearance. So you can do this between 30 minutes and 90 minutes before entering oceanic. So in this case, that part where we're going to enter oceanic for us is when we fly over at Resno, okay? So just to keep that in mind. Now you can imagine some airports in Europe are very close to the oceanic boundary, and in that case, if your airport is very close to the oceanic boundary, you will already ask oceanic clearance with the relevant controller while on the ground, so before you depart. Now a general rule of thumb for airports in Europe, any airport west of 3 degrees west, so west of the 3 degree west line, need to ask clearance from oceanic controller while on the ground. Any airports to the right of the west, so to the east of 3 degree west line, have to ask oceanic clearance while in the air. So for example, if you're departing out of Dublin, Shannon, or an airport in Scotland, you have to ask clearance on the ground. If you are departing out of London, Amsterdam, Paris, Frankfurt, then you have to ask oceanic clearance in the air. So this is the general rule of thumb. So 30 minutes prior to oceanic entry, you have to ask your clearance at least. But do keep in mind there might be regional differences. So I've linked some documentation in the description which you can check out. Again, on VATSIM this may not be so accurately simulated. Just keep in mind you have your oceanic clearance in time, otherwise you cannot cross the Atlantic Ocean. Okay, so at least make sure you get that in time, and preferably 30 minutes before entering oceanic airspace, or on the ground if you're west of 3 degree west. Okay, so I'm now just going to depart the aircraft, and we're departing out of Amsterdam, so our oceanic clearance is just going to be given while we're in the air, and I'm going to show you exactly how to do it. Alright guys, so the flight has progressed in the meantime, and I took off from Amsterdam runway 36 left, and we're now approaching Shannon airspace shortly, and basically soon we'll be able to ask oceanic clearance, and I'm just going to tell you a little bit about it. So I already told you when to ask clearance, so on the ground or in the air. Now when you're in the air, Again, you just want to make sure at least 30 minutes before your entry point you want to ask Oceanic Clearance. Now, in principle, it's the pilot's responsibility to ask clearance. The controller might give you a handoff to the relevant controller. If they don't, you have to ask for a frequency change so you can ask the Oceanic Clearance in time. All right. I'm just going to show you an example of what this looks like. Again, there can be regional differences. What you will see here is just general Oceanic Clearance. Again, you have to read the proper documentation if you want to find out regional differences. Now, of course, the question is, which frequency do I contact? Well, during cross the pond, you will be you get a handoff to the relevant controller. It's likely a separate delivery controller. Actually, if you look in the NAT Track Message, if you're flying eastbound, you can see that for the different entry points of the Gander Oceanic region, there are different delivery frequencies, and during the cross the pond event, likely those delivery frequencies will all be online. But of course, on a regular day, usually there might be only one Oceanic controller. For example, only Gander might be online. That controller might also do the Shanwick Oceanic region, and there are no separate, Oceanic Clearance delivery controllers online. So it really just depends. You can ask the controller, the domestic controller, which frequency to contact. Otherwise, if in doubt, always ask. You can always send a private message to an Oceanic controller like, hey, I'm inbound this Oceanic entry waypoint. Can I ask Oceanic Clearance at your station, at your frequency? It never hurts to ask, especially when it's not busy. So be rest assured you will get on the right frequency when you are flying across the pond event with all frequencies online. And if you're just flying on a regular night, just ask or just use your intuition about which frequency to contact. So I'm just going to use some kind of frequency right here, right now. So it really depends which controller is online, so don't remember that frequency too much. But just to stress again, it's the pilot's responsibility to ask the clearance. Okay, so first of all, now let's say I'm almost in Shannon airspace. When I'm past waypoint Barso, we are in Shannon airspace. Let's assume that we already received the handoff. Now we're now with the Shannon controller. All right. Now again, you want to look at your FMC and see when you arrive at the Oceanic entry waypoint, the Resno. So I'm just going to go to route data. Already looked at this before the departure, but now we have the actual time at which we expect this waypoint, Resno. So 11:36 Zulu. All right. So if we look at the time right now, it's now 10:52 Zulu. All right. So in about in about 44 minutes time, we arrive at this waypoint Resno. So at this point would be a good idea to ask Oceanic Clearance. Now you could just send a private chat message to the Shanwick controller, but I'm just gonna do it via voice, simulate it via voice, and ask first for a handoff for the Oceanic Clearance. And KLM 641, request frequency change for Oceanic Clearance. KLM 641, contact Shanwick Oceanic on 131.62 for your clearance. 131.62 KLM 641. Okay, so we got our frequency. We're going to go to that frequency right now. 131.62. Again, this is all simulated. I'm not actually flying on VATSIM, but just to give you an idea of the phraseology, okay? So we're now with the Oceanic controller, and the idea is that you ask your Oceanic Clearance right now, and then you return to the domestic controller, right? Because you're legally still flying in the domestic airspace, okay? So when you're on the Oceanic frequency or the delivery frequency of Oceanic, make sure you listen out for a little while. Make sure you're not interrupting another readback or instruction, and then you can do and request your Oceanic Clearance. Now, what does this look like? So it looks basically like this. So you're first gonna request your clearance to the relevant airport, in this case New York JFK or New York Kennedy. Then you tell the controller which track that you want. So in our case that will be NAT Track Echo, that's what we planned. Which flight level that you want? Well, flight level 340 is the planned flight level for us. Your requested MAC number, so MAC decimal A3 is our requested MAC number. And you're gonna mention your estimated time at your entry point, so at waypoint Resno, again, that is 11 36 Zulu, or just 1136 will do. And that's basically it. That's how you ask your Oceanic clearance. Now, I'm just going to show you the exact phraseology right now, okay? So we're now with the Shanwick controller, and I'm going to ask Oceanic clearance. Shanwick, good morning. KLM 641, request Oceanic clearance to New York Kennedy. KLM 641, Shanwick radio, good morning. Pass your message. Alright, so when the controller says that, you know, he's braced for your Oceanic clearance, and then you can continue with your Oceanic request. KLM 641, request Oceanic clearance to New York Kennedy via NAT Track Echo. Request flight level 340, Mach decimal 83, estimating a RESNO at 1136. There we go. So that's the basic Oceanic clearance request. So we fly via NAT Track Echo, we request flight level 340 and Mach decimal 83, and we estimate a RESNO at 1136 Zulu. Okay? And the controller will reply with this. KLM 641, roger, stand by. So in this case, the controller has written down all the information and is going to put all that information into their, you know, navigation, you know, systems, in order to make sure that the clearance that you requested is actually valid, and that the time that you're arriving at the RESNO and that your speed and flight level are okay, so that you're not interfering with any other traffic. So after a few seconds, or the controller will reply to you. KLM 641, Shanwick. KLM 641, go ahead. And now you have to brace, because this is the point where you're gonna get the clearance, okay? And you need to have a paper with you. There's also a particular sheet for VATSIM Oceanic crossings, which is kind of fun to use as well. You can use that one as well. So make sure you check that out. Otherwise, just get a piece of paper and design your own system to write down the information quickly. Now, the clearance will look like this. The controller will mention a call sign that you're cleared to, in this case, Kennedy, via the entry waypoint, in this case, RESNO, and then the NAT track, in this case, NAT Track Echo. The controller will also give you a TMI number. Now, the TMI is basically the day of the year, okay, on the 365 days calendar. Currently, the TMI number is 144, so we are at day number 144 of the 365 days that are in a year, okay? And basically this is used to make sure that you have the NAT track of today, okay, so that you're not using the NAT track of yesterday. And by reading back the TMI number, you know, you don't have to read back all the separate waypoints of the NAT track, basically. Now you can find the NAT TMI number in the NAT Track Message again. So at the bottom in the remarks section, you will see that the TMI is 144, and indeed you are reminded actually to include that in the Oceanic clearance readback. Okay, so TMI is 144, and then they're gonna give you some instructions, and these instructions might be the same as your request, or they might differ. So make sure you write that down. So from the entry waypoints, in this case RESNO, they will give you a flight level, a Mach number, and they might give you some other instructions. I'm going to look at that in a minute. So let's just assume our request is, you know, verified and is okay, and we don't need any other specific instructions. So this is what the reply will look like. KLM 641, Shanwick clears KLM 641 to New York Kennedy via RESNO, NAT Track Echo, TMI 144. From RESNO, maintain flight level 340, Mach decimal 83. And that's it, that's the clearance. Okay, and then you can reply. KLM 641, clear to New York Kennedy via NAT Track Echo, TMI 144, via RESNO, flight level 340, Mach decimal 83, KLM 641. KLM 641, readback correct, return to domestic. Continue with domestic, KLM 641. There you go. So the controller gave us the clearance. Our requested flight level 340 is okay, and our Mach number is also okay, so we don't have to alter anything. And now we could just go back to Shannon and can just, you know, tell the controller that you're back. Once we are close to RESNO, we can expect a handoff to Shanwick Oceanic controller. Now I'm going to do this whole procedure again, just for demonstration purposes, and I'm going to add a few things, alright? This is, the clearance that I just showed you is the basic clearance that you can always use, okay? But in some regions, and sometimes you might encounter some different things. For example, in some regions you have to mention your able flight level, which flight level you're able to fly at. In this case, in our case, we just go to the VNAV page, and you can see that the max flight level is 351 at this stage, alright? So, although we request flight level 340, we can say that we're able flight level 350. And we're also going to mention our SELCAL code, okay? Now the SELCAL code, you can find that on the internet for your specific airframe, and you can mention that SELCAL code in your Oceanic Clearance request. And what the controller will then do, once he has given you the clearance, is he will send that code to you. If you're properly set up with vPilot, and once you connect it, you've properly included the SELCAL code, you will hear an audio tone, or at least you will see a message including your SELCAL code. And the SELCAL code is used to, in the real world, if you would listen to those HF radios forever, you would get crazy. So, they tune down the volume of the HF radios, but then when the controller sends the SELCAL code, which is unique for your aircraft, basically you know that the aircraft controller wants to get in touch with you, and in that case you can go back to the frequency. Now again, this is all a little bit different, in the real world with the data link and all that stuff, but it's kind of fun to include, so I'm going to include that in the new Oceanic Clearance that I'm going to request. And also I will, in this case, simulate that the controller gives us some restrictions, okay? So I'm going to assume now that I'm back with the Oceanic controller, with the Oceanic Clearance delivery, and I'm going to request my clearance. Shanwick, good morning. KLM 641, request Oceanic Clearance to New York Kennedy. KLM 641, Shanwick radio, pass your message. KLM 641, request Oceanic Clearance to New York Kennedy via NAT Track Echo, flight level 340, request Mach decimal 83, estimating a RESNO at 1136, able flight level 350, SELCAL, Echo Foxtrot, Lima, Quebec. KLM 641, roger, stand by. So, as you can see, I've now included flight level 350 and our SELCAL code in the Oceanic Clearance request, Echo Foxtrot Lima Quebec, for this particular airframe. And now the controller will reply. KLM 641, Shanwick. KLM 641, go ahead. KLM 641, Shanwick clears KLM 641 to New York Kennedy via RESNO, NAT Track Echo, TMI 144. From RESNO, maintain flight level 340, Mach decimal 83. Cross RESNO not before 1138. SELCAL check Echo Foxtrot Lima Quebec coming up. So in this stage you have to wait a little bit with the reply, and just make sure you have written down all the information. At this stage the controller is going to actually send the SELCAL code, and you just have to make sure in vPilot that you receive that message. And as you have noticed, the controller gave us a restriction. We have to cross RESNO not before 1138 Zulu, and I'm going to show you in a minute in the FMC how to do this. You can expect these kind of restrictions all the time. Either cross a particular waypoint along on your NAT track not before a certain time or not later than a certain time. You might expect a different flight level. Your max speed might be different than you requested, and in some cases you might receive an entirely different NAT track. So make sure you're ready with pen and paper to write the information down and to adjust your flight plan as necessary. Okay, in this case we have received the SELCAL code and we can reply to controller. KLM 641, SELCAL checked, clear to New York Kennedy via NAT Track Echo, TMI 144 via RESNO. Flight level 340, Mach decimal 83, cross RESNO not before 1138. KLM 641. KLM 641, read back correct and return to domestic. So there we go, that's our clearance. So whether you include the SELCAL and the able flight level is entirely up to you. You don't really need it, okay? The controller might ask you for it, so if you just want to keep it simple, just stick with the original clearance that I asked. Now, but of course, we now have a restriction, and we also have a particular Mach number at which we want to fly. So I'm just going to quickly show you how to include this in the FMC. So basically, at this point, we want to start flying Mach decimal 83. So I'm just going to put that in here, execute, and as you will be able to see, our speed will now slightly increase. It's only slight, I mean, it's not a huge difference. But what we also have is a required time of arrival. We cannot cross Resno before 11:38 Zulu. And if you look at the route page, route data, we're actually crossing Resno at 11:36. So we want to make sure that we cross this waypoint a little bit later. And I'm going to show you how to do that. So again, this is specific for the 777. You know, in your aircraft it might be different, but most larger airliners, you have something called RTA, or required time of arrival function. In this case, in the VNAV page on page 2, we go to RTA progress, and here you can enter the fix for which you want to have a restriction. So Resno, and here you can put in the required time of arrival. So we want to arrive at 11:38, simply because we're not allowed to, you know, cross this waypoint anytime before that. So I'm just gonna put it in 11:38.0 and hit execute. As you can see, we have a target speed right now, which is pretty low. Hit execute, and now our speed will reduce. And now if we go back to the route page, or the legs page and route data, you can see that we now estimate Resno a little bit later. Okay, you wanna keep an eye on this. Make sure you actually cross Resno properly. Okay, and just see if the RTA progress is correct. Okay, so we're now estimating Resno at 11:37.8, and we're now slowly reducing the speed, as you can see. And of course, the closer you are to this waypoint, the harder it's going to get to correct for the time difference. But in this case, you know, we're arriving in pretty well, and you know, 0.2 difference doesn't matter that much. But just keep in mind that the RTA page function is there in the FMCs of airliners, and you have to make use of that quite often, especially during cross the pond, okay? Because they really want to maintain that 10-minute separation between different aircraft. Now, the Oceanic Clearances that I just showed you are example of Oceanic Clearance when you follow a specific track. Now, if you have a random routing, the TMI number is not of relevance, and of course you're not going to mention that you're going to fly via NAT Track. In that case, the way your clearance looks is, as you can see, here's an example. You just mention the separate waypoints that you're going to be flying over, and then you know, you have to confirm that those waypoints with the controller, and then the controller, you know, will reply and confirm those waypoints with you. And that's basically it for a random routing. So as you can see, it's a little bit different. You have to mention each and every coordinate, which for the NAT tracks is not necessary thanks to the TMI number. So whenever you have a random routing, your clearance will continue the separate coordinates that you're going to fly over when you cross the Atlantic. Alright, so as you can see, we're closing in on Resno waypoint, and this means that we're gonna soon enter Oceanic area. Now, if you haven't received your clearance by this time, you know, you really have to hurry up, because we're, you know, approaching this waypoint in 10 minutes, and you know, you cannot enter the Oceanic region, and the domestic controller might not give you a handoff and just instruct you to make a maneuver to go back, because you have to have that Oceanic clearance. One thing I wanted to tell you as well before we move on is that if there are any restrictions that the controller gives you, and if the domestic controller asks you about this once you're back after the Oceanic clearance, you know, you have to inform them. For example, if you have a really big restriction at waypoint Resno where you need to arrive not later than like 10 minutes, then you might want to inform the controller, and then they might be able to do something about it. Of course, the Oceanic controllers will also coordinate this with the domestic controllers to you know, deal with this, so you don't have to worry about it too much. But when the controller asks you about the restriction, make sure you're able to, you know, tell them about the restriction that you were given. Okay, so we're now closing in on waypoint Resno, and soon we'll get a handoff to Shanwick Oceanic controller, and then we have to do our first position report. So basically, position reports you have to do every time you enter a NAT track or cross a waypoint or coordinate along the NAT track. You have to do position reports every 45 minutes since the last contact. So if you have not passed a waypoint yet, but 45 minutes have passed, you have to do a position report, okay? Now in practice, if you look at the NAT coordinates right here in the route data, you will see that the time between them is not usually not more than 45 minutes, or very close to 45 minutes. So in general, it should be fine to just do a position report at the coordinates, okay? But just keep in mind that you have to do this. Also, when you have a change in flight level, you are given a change of flight level or request a change in flight level, you also have to do a position report, okay? So in a short moment, I'm going to simulate how a handoff to a Shanwick Oceanic works and how we can do our first position report. KLM 641, contact Shanwick on 131.8. Bye-bye. Contact Shanwick on 131.8. KLM 641. Bye-bye. Okay, so now we go to the right frequency. Let's presume we're on Shanwick. The frequency is clear and we can report with Shanwick, and we're going to do our first position report. Basically, what you want to do in a position report is tell which waypoint you're currently inbound to and what time you're expecting it, or maybe you're already over at that waypoint. And then you mention your flight level, your max speed, and then also you mention your next coordinates and at which time you're expecting that to cross that waypoint. And then also you finally enter your position report with the waypoint or coordinate after that, okay? So don't worry, this is what it's gonna look like, okay? Shanwick, good morning, KLM 641. KLM 641, Shanwick, good day, pass your message. Okay, so now the controller has told us to pass the message or to go ahead with the message, and now we have to do the position report. Make sure by this time you're at the restrictions that the Oceanic Clearance gave you. So we're going to accelerate now to Mach decimal 830, and I'm at flight level 340, and I'm estimating Resno. I have to take a look. I'm estimating Resno at 1139 Zulu. We're pretty much over at Resno, so we can just report that, okay? And of course you need to mention the arrival time at the next coordinate after that. So best thing to do is to keep this route page open so you have the latest information about the arrival time. Okay, so here we go. And KLM 641 over at Resno, 1139er, flight level 340, Mach decimal 83. Estimating 56 north 20 west at 1200, 58 north 30 west next. Okay, so that's it, right? You report the waypoint you're over at, so in this case Resno, at what time? 1139 Zulu. Your flight level that you're at, your max speed, then the next waypoint, which is 56 north 20 west at 1200 Zulu, and then the waypoint after that you mentioned that, just mention that waypoint, so 58 north 30 west, okay? So that's the way you do a position report. And KLM 641, Shanwick copies position Resno at 1139er, flight level 340, Mach decimal 83. Estimating 56 north 20 west at 1200, 58 north 30 west next. Correct, KLM 641. And that's basically it. And if there's anything that you need to alter, like change your speed, or you have another required time of arrival restriction, then you can just enter that in the FMC. So now we'll just happily cruise along to our next waypoint and do our next position report once we are over at that waypoint. Alright, so we're now inbound to our first coordinate, 56 north 20 west, and since we're about to cross this waypoint, we want to do a position report. So again, make sure the frequency is empty and we're ready to go. You have the route data page open, and with the position reports and with the Oceanic Clearance, I mean, you have plenty of time to think about it, right? There's quite a little bit of time between each and every waypoint and before you reach the point where you have to ask Oceanic Clearance. So you can basically just write down the entire position report already, right? So it requires a little bit of practice, and as you do this, you can also just try and do this offline, practice with yourself, and act as if you're talking to ATC doing position reports. It's pretty simple. It's a new type of phraseology that you have to learn. Alright, and you might have a little bit of hiccups, but always make sure you have that pen and paper next to you so you can write down the information of the controller. Okay, so we're gonna do a position report now. Since we're passing this waypoint, we're estimating 56 north 20 west at 12:01 and 58 north 30 west at 12:46, and then the next coordinate is 58 north 40 west. Okay, so here we go. KLM 641 position report. KLM 641, go ahead. And KLM 641 at position 56 north 20 west at 1201. Flight level 340, Mach decimal 83. Estimating 58 north 30 west at 1246. 58 north 40 west next. Again, I'm 641, Shanwick copies position 56 north 20 west at 1201, flight level 340, Mach decimal 83, estimating 58 north 30 west at 1246, 58 north 40 west next. Correct, KLM 641. So that's basically it. We now have done our position report, and you know, the controller is now up to date with our latest information about our arrival times at the waypoints. As with any transmission, make sure you speak clearly, take your time, do not speak too fast, make sure you really pronounce those, you know, the time and the waypoints properly. So 56 north 20 west, estimating it at 1136, you have to use the proper way of phraseology. Don't say like estimating rest now at 11:36. That's not how you should do it. All right. So be clear in your speech, basically. All right. So that's on our position report, and basically you have to keep doing this position reports until your very last waypoint. And of course, at some point you're also going to get a handoff to Gander at 30 west. And then as you're at Gander, as you're passing 30 west, which in our case is 58 north 30 west, you're gonna again do a position report with Gander and just tell them when you're crossing that waypoint, when you're crossing the next waypoint, and what your next waypoint is going to be. Okay, so that's basically the basic stuff when it comes to phraseology. It might seem a little bit complicated. Make sure you use that forum that's linked in the description to make it easier, and don't worry too much. It's kind of fun to do, and it's okay to make mistakes, especially when you do this for the first time. Now, a couple more things that I want to mention for this Oceanic tutorial. There are a couple of things that you need to do en route. One of those things is that you have to squawk 2000 in this Oceanic airspace when 30 minutes on your way into the North Atlantic. Okay, so I've set a timer here on the first officer side. We're now 21 minutes. So if it's reached 30 minutes, or maybe the controller will already give you the new squawk code, you just enter 2000 right here. Okay, there we go. And then once you get with the domestic controller over on the in the US, you will probably get a new squawk code. Alright, again, there might be some regional differences. For example, in Iceland, I think you have to remain your squawk code that was giving you domestically. So again, read up on those procedures. Then I also want to mention strategical lateral offset procedures. And this is something that's done in the real world, where you can just fly a little bit of offset to the right, only to the right of your route as you fly across the Atlantic. What this does is just adds a little bit of a safety margin, just to separate traffic a little bit more. Pilots can do that at their own discretion and fly an offset of 1 or 2 nautical miles to the right of their track. So the way you can do that, here in the route page, you can type right and then 01, and this will create, you have to zoom in quite a little bit on the navigation display to actually see it. This will create a small offset just to stay clear of other traffic laterally. Okay, so that's the way you can do that, or if you want to offset of 2 nautical miles, you can do that as well. So just want to show you that so you're aware of how to fly an offset. For now, I'm just gonna keep it this way. Another thing to mention is when when your destination is quite close to the coast and quite close to the NAT track, you're not actually allowed to start your descent in the NAT track, okay, or in the oceanic airspace. Descents in this airspace is only for emergencies only, okay, so do not say like a KLM 641 requesting descent while you're still flying on the NAT track. That's not the way it goes. So you have to be in domestic airspace before you do that. And one more thing that I want to mention is, make sure you fly accurate. Make sure that the automation is doing its thing. Basically, a track that you're flying right here, this lateral deviation may not exceed 2 nautical miles. The Mach number must also be within 0.01 of the assigned speed. So preferably your speed should be between 0.825 and 0.835. Okay, this aircraft is very well able to maintain this speed. As you can see, it's now 0.831. That deviation is not that bad, and that's okay. Okay, and that's why you do the position reports, right? To take into account those little differences. Now, when the situation occurs when there's a big difference between what you reported as your estimation time and what your actual estimation time is going to be, you have to do a so-called revised estimate. And you can see some of that phraseology here in this excerpt from a document that's linked in the description. So when it comes to time points at waypoints that you've reported in your position reports, whenever the estimated time of arrival at coordinate that is reported in the position report deviates by more than 3 minutes, either earlier or later, then you have to mention this to ATC. So then you have to let ATC know, hey, I have a revised estimate. I'm now estimating this waypoint at this and this time instead of this and this time. And this can happen due to winds, for example, that are much more different than expected. So keep that in mind. And then lastly, also your altitude should be maintained properly. Okay, you may not. You have to stay within 100 feet below and above the assigned altitude. If you fly any lower or higher than that, you have a problem with separation, and that's not what you want. So also make sure that the QNH is set to standard once you're cruising, because you really don't want to be on a different QNH and end up in someone else's flight path. Okay, because the controllers don't have radar coverage, so they cannot see where you're flying and what altitude you're flying. Okay, so as on VATSIM they can, because it's VATSIM, but in the real world they actually can't. So you have to take that into account. All right. So that's basically the in-flight stuff. And so what you can expect now is more position reports and handoff to Gander, and that's basically it. At some point you'll get a handoff to domestic airspace, and then you can continue your flight there. So that's it for most of the phraseology part and the in-flight stuff that you can expect on the NAT track and the North Atlantic airspace.
So there you go, that's my Oceanic tutorial video for VATSIM here on the AviationPro channel. I hope you enjoyed it. A couple of last tips that I want to give, don't do the long haul flights too often. It's kind of crazy to do, especially if you're flying throughout the night, which I did a couple of times. But, regard it as a little project. And again, the procedures that I've shown here are kind of general procedures, but there might be in the real world, there might be slight differences. But on VATSIM, it's just impossible to really simulate every single little detail that happens in the real world, simply because this is not the real world, let's face it. So just a couple of tips, read well. So depending on what your route is and which areas you're going to be flying and which airports you're going to depart or arrive from or to, read the manuals, go to the VAC website, see if you can find any specific information about oceanic procedures when flying from this airport or when crossing Santa Maria, FIR, or when you, for example, fly to Iceland. The procedures might also be a little bit different. So just read about that, and the stuff that you've seen in this video is a good general knowledge base that you will have and will safely get you across the NAT track. But once you do more advanced routes or random routes in unknown areas that not a lot of people fly to, it's good to just read well and read the manuals. There's plenty of information out there on local VAC websites. Another tip I'd like to give you, and I also mentioned that previously in the video, if in doubt, just ask. It doesn't hurt to ask. Maybe during cross the pond, controllers probably won't appreciate too much questions, But whenever you fly on a regular day, when there's no big event over the oceanic region, but when there is ATC, just ask if you're in doubt, because ATC usually knows a lot better about the procedures than the pilots do. So never be afraid to ask, just to clarify things and to gain knowledge yourself. And the last thing that I want to say, the procedures described in this video are in a perfect situation, but in reality, especially during the cross the pond event on VATSIM, it's just simply too busy to accommodate every airplane properly. It can happen that your oceanic clearance only arrives 10 minutes before your entry point. It can happen. So last tip that I want to give to you, be patient, be respectful to other pilots and other controllers, don't mess about on the frequency, just let other instructions finish before you start to ask your clearance, etc., or do your position report. Just take it easy. You will be getting your turn eventually. Sometimes it might take a little while, so just keep that in mind, that it's not perfect on VATSIM either, probably not in the real world either. I mean, you don't know what happens on real world oceanic radios, but I bet pilots have questions there as well. Even how well you're trained, you're a rookie when you fly over the oceanic for the first time, so there's always stuff to learn. So just keep that in mind. So thanks for watching this video here on the AviationPro channel. Now, if you liked this video, I would really appreciate your support. Head over to my Patreon page, patreon.com/aviationpro, to see how you can support this channel if you like this video and if you like to see more videos. And otherwise, head over to aviationpro.nl/support for more information. Your help would be greatly appreciated. So have fun flying oceanic, and I will see you next time.